right. So, welcome everyone. The title of the talk is a bit different than in the program, but it's very similar. But there is quite a lot of Kubernetes in there, but there is also DevOps. So, yeah, I'm not sure if you're expecting more of a technical Kubernetes talk or more of a DevOps talk. This is both, but I'll try to adjust it a bit to what makes sense for the audience. So let me first introduce myself. I am Adam SANDOR. I'm actually Hungarian, but I live in Amsterdam. I work for a consultancy company called Container Solutions. We're basically advising companies in the field of cloud-native technologies. So Docker and container orchestration plays a big part in that, but so do all modern cloud-related technologies and DevOps processes. So we help companies implement DevOps processes on top of these technologies. I've been a developer for most of my career, and about a year and a half ago I turned to the ops side, got really interested in all the container orchestration stuff, and went to do this consulting job, which I really enjoy. So also after the talk, I would love to talk to you guys, hear about your problems, and help out if I can. Yeah, and the reason I got interested in this stuff is because this is finally developer-friendly ops. So when the times of like configuring and building Linux kernels and stuff like that, that was never my cup of coffee. But since the cloud arrived and all the new cloud-native technologies, that's something that appealed to me as a developer also. I also organize community events in Amsterdam, so if you're there, reach out to me and come join. Maybe there is an event happening when you're just there, and I go to conferences. And I'm also a big fan of a certain video game called Doom. I like to shoot these guys as much as I can find time for them. So, that's for the intro. Yeah, so this talk is about how technologies like Kubernetes, and especially Kubernetes itself, enable DevOps processes. First, a few questions to you guys. Who is more of an ops person or working in an operations role at your company? Okay, yeah, it's really DevOps. So the rest, I imagine, is developers, right? Writing code, pushing it towards those operations guys. Who works at companies that have no ops department, that just like you as developer is also responsible for production simply because there is no one else? One? Okay. Two? Alright, so you're my kind of audience. I need the people who do encounter the organizational issues around DevOps. I guess that's why you're at the conference. So that's great. So let's start with one more question. Who is already working with Docker and Kubernetes, or have at least played around with it? Alright, Kubernetes, just the Kubernetes people? Okay, not that many, perfect. Yeah. My biggest fear as a speaker is always that the audience will already know all that I want to tell them, so great. So this talk starts a bit with the DevOps stuff. So why do we need to enable DevOps? A lot of people talk about like how DevOps is a cultural shift and so on, and they're absolutely right. But I wouldn't downplay the technological aspect too much, because it plays a very important role. You cannot do DevOps by writing bash scripts, I would say. That's, I will explain that statement a bit more in detail. So yes, DevOps is about culture, is about developers and operations working together, but if the right tools are not there, then this cooperation becomes harder and harder. And that's why I will be slowly getting around to Kubernetes. So yeah, origins of DevOps stuff. At this conference, I think I can safely skip this. You probably heard it already. There was the keynote, which was great and explained this. Developers want to change stuff, operations want to keep things stable, business wants both. Google started to do the SRE program, quite a few years ago. And so operations, they try to make operations software developers who develop operations software and provide services to the rest of the organization, instead of a gatekeeper who has to grab artifacts and put it on a production server. So this one I would stop for a moment to explain where container orchestration and all the rest of the stuff fits in. So different ways to do, basically not really to do DevOps, more like do infrastructure management. So I can't move away from the microphone, so I just point from here. The more simplistic way to do infrastructure management is using configuration management tools, or like one more level simpler could be use Bash. That's how you arrive at configuration management tools, because simply the abstraction level and the tooling around Bash doesn't really scale to larger applications, larger code bases. So you go and start using something like Puppet, Chef, or Ansible. Another approach that was taken by Netflix, because they were on Amazon, they started using pre-baked VMs. So they don't configure their instances on startup, running some configuration management on top of them, but they install everything on the VM up front, create an image out of it, and then just start up instances of that. Google went the way of containers because they simply, I think it's more of a historic thing. So Netflix was running on Amazon, so making AMIs and images was very natural for them. While Google was always exploiting this, their own data centers, which initially consisted of cheap Linux machines, but a lot of them. So they invented containers as a way to basically create something like VMs, lightweight VMs on top of the Linux kernel. All their machines were running Linux, so they went the way of containers. Containers are very similar in this sense to pre-baked VMs. They contain a large part of the operating system, everything besides the kernel, and they are immutable. So again, you're making an image, pre-baking it, and then launching instances of it. And then next two levels are passes, where a provider just takes your code and runs it somehow. It takes it out of your hand. And the newest iteration is functions as a service, where they don't just run it for you. They even like your code doesn't even keep running. It just runs, let's say, to serve one request. These are Amazon Lambdas, Google Cloud Functions, etc. So there is a red line here. Everything below that red line is cool. Running configuration scripts on instance startup is not cool. So you want to have immutable infrastructure to solve a lot of problems. This talk is not about going into the details of that, but please, if you have one takeaway, just at least take this away, why container orchestration is a good idea. And why it's actually becoming more and more popular compared to pre-baked AMIs, which are a very convenient tool to use on Amazon and so on. I will go into that. So kind of the world is heading from top to the bottom of this. Going down, you are gaining focus on business logic because somebody is taking care of more and more stuff for you. But upwards, you are having more and more control over your environment. Configuration management doesn't give you the most control over your environment. That's just the imperfection of this image. Pretty much pre-baked VMs give you as much control over your environment as configuration management, and you're not losing much by doing container orchestration. Passes and fases take a lot out of your hands, which might be exactly what you want. It's just depends. Everything depends on your requirements. So also the big move to the clouds in recent years that has sparkled the DevOps movement, because finally everything is fully programmable. So you can do automation without huge pain, and that's a new thing, and that's why automation is at the center of the DevOps movement. But it also brought a new focus to distributed architectures. distributed architectures were usually for the big companies, so really needed to handle huge loads, or really needed high availability, and much of the IT world was completely fine running on one big machine. Some were fine running on a smaller machine, some need a bigger machine, and some got really, really expensive large machines. But once you move to the cloud and suddenly you realize you have this huge capacity there that you could use, but then you realize your application is storing 10 gigabytes of data in memory and you just have to run one piece of it. So even with Amazon giving you like a huge VM, you will not get what you could out of the cloud. Plus it will be very expensive, you can't do scaling, you can't do rolling updates to your components, etc. So the cloud really forced this new way of thinking about distributed applications to like every kind of company in the IT industry. And then there is the newest hype to microservices. Let's do microservices. And so in companies where operations departments traditionally existed to maintain those large servers, this move towards distributed applications really put more and more burden on these operations departments, because maintaining that one server that was still doable, maintaining lots of them became harder and harder. And once developers decide to split their applications into 100 components so they can push to production every day and making sure they don't break something because they just update their SSO code or they just update the reservation system, then suddenly this complexity explodes and is no longer manageable in the traditional way, hence DevOps again. Basically, solution is push some of the operations concerns to the developers. You want to run more services? Yeah, go run them. But we are getting out of that business. And also you can see here that polyglot applications become possible. I've seen at companies that write shit tons of Puppet scripts, but they are very specific. They are copying files into the right directory on Tomcat, and then configuring some configuration files for Tomcat, and that's how they deploy the Java applications. And once a developer says like, hello, I would like to run a Node application, and they're like, hey, dude, we have like this 1,000-line Puppet scripting to get our Java apps working. We're not going to do that for Node all over again. And then everything just kind of gets stuck. But the good news is all these new cloud-native technologies, the containers, are really solving this problem in a nice and elegant way. So it's really this problem is becoming a non-issue. And we're starting to have completely new issues. So yeah, this is what operations looks like when they hear microservices and these two. But there is hope. So before I go into Kubernetes, what's the key to solving this problem? It's not really technology. So I was bashing Puppet and bashing Bash. That's cool. A lot here. Yeah, it's probably the worst way of doing this, but still the key thing to do is that don't go and script tasks that you are doing manually. That's the worst approach that gets you into a deep pit. When you see that, okay, so we are deploying our applications. I just put this ripio back so I'm not reading all that text because I'm not actually telling that yet. So many companies, when they start thinking DevOps, and especially if they have a traditional ops department that were used to just managing servers, and now suddenly they're told, okay, automate, that's the key, let's automate everything. And now they remember, okay, so we were copying this var file into that directory, and then we were updating this configuration file with a few values, and then we were doing this, and then we restarted Tomcat, and then we're doing that. Well, let's just automate that, and then, okay, come the bash scripts, come the Puppet scripts, but that's not a scalable approach. Again, your infrastructure code will be completely tied into whatever applications you happen to be deploying at the moment in whatever way. And everything, and you cannot, again, scale that properly. You will have a huge code base, you will end up maintaining maybe the infrastructure automation code more than your application. When you have that, when you have like really complex infrastructure code, then you are doing something wrong definitely. So the key is, because that's not your business, right? You want to run applications that deliver business value and make money for you. So unless you're AWS, you don't want to write complex infrastructure code. So the key is creating a platform that will be an interface from operations to the development side. So whatever way you give your developers, and of course we'll be talking about container orchestration and Kubernetes here, give them a standard way how they can describe their applications to your platform, however the platform is implemented. It might be a PaaS, it might be container orchestration. And once you do that, once you have like a standard way to deploy application, and that way is of course flexible enough for all the applications you will be running, you start to reap the benefits big time. It becomes scalable, it becomes automated, and you can start adding all kinds of features, because if every application is a Docker container, you can just tell all the developers to log to std out, and you can have log aggregation for free. Of course, you will have to run the whole log aggregation system, or you outsource it to Logs.io or whoever, but the interface to the application world will be clear and will be technical and not a checklist in some wiki page that the developers need to tick off every time they want to deliver a new release. So, this is my beautiful diagram of a microservice platform. The whole point is there is uniform deliverables coming from the development side, and there is a combined with manifest files that describe how this should be run, because it's rarely enough to just have the binary code. Combined with some manifest files that tell the platform how much memory does this thing need, how many instances should be running, and a whole bunch of other stuff I'll be showing in a moment. And the platform is designed to handle these kinds of artifacts. In our case, Docker containers and Kubernetes. So, and with this, we achieve a nice separation of duties between development and operations. And of course, DevOps is about bringing these two together, but if there is not a clear separation of duties, then cooperation doesn't work. If on a team, something is everybody's responsibility, and there is not a way to clearly define in this instance who's taking care of that thing, then it becomes a conflict. So what I've seen at companies that implemented, for example, a lot of Puppet scripting, was that the developers couldn't really work with the Puppet scripting. And they're trying to do the DevOps, but it just didn't go together. And still, every new service that had to be put into production had to have huge ops involvement to create all the deployment scripting. So, but once you have a platform, you can just tell developers, create that manifest file, build it as a Docker container, and we're getting out of the way. No longer has any operations person be involved in a release or in creating a new service. What operations has to do is keep that platform up and running. And usually companies want to outsource that platform operation stuff, which operations people should be a bit wary of, because it does make sense. But even the outsourcing is like, let's say you want to run your own Kubernetes cluster but outsource it to Google, on Google Container Engine. Yeah, they will take care of a large part for you, but there is still all kinds of cloud stuff that needs to be configured, from load balancers to CDN networks, etc. So ops is not finished. There is still a lot of stuff that developers just don't have the time while they're learning their newest JavaScript framework. And they have to do that every month. So ops is still very necessary. Yeah, so this is, I think, the ideal model for a DevOps cooperation, and that's why you need the right technology to enable it. So operations advise and developers on using the platform and build the platform and maintain the platform, while developers can push to the platform and be responsible for their own production environment, because the production environment is now a user-friendly platform as opposed to some stuff running on a Linux machine somewhere, which they have no idea about. But still, there is a learning curve for both sides here. It's not free. Technology will not solve it, but it will help. So, Why are containers better than building pre-baked VMs? It's because we never really developed the technology for VMs to do the golden image principle that containers have. So you can see this is a Docker file that basically defines a full Linux system for running Node.js or Node. And you can see that all the tricky part is hidden inside this from statement here. So when you're writing a Docker file, yes, you can do whatever you can do on Linux here except change the kernel, but you don't have to because you just extend an official Node image, and that's a huge thing that you cannot really do with VMs. Lighter, and of course container images are much lighter, which enabled container orchestration together with the faster startup, because we can have much more dynamic systems than we could before. It does make a big difference whether your container starts in 2 seconds or your VM starts in 2 minutes or 5 or 10. So, and why Kubernetes? My advice currently for anybody who doesn't have really special requirements, special requirement might include running on Amazon at the moment because they have their own container orchestration and don't have managed Kubernetes. Well, if you can, just go Kubernetes. It is right now the most mature container orchestrator. It has the largest community, and it's basically bulldozing everything in its path in the container orchestration world because it works and because it evolves so fast and because it's currently just the best one. It can manage different workloads, stateful workloads, stateless workloads, batch jobs. There is even serverless frameworks built on top of Kubernetes. It has namespace isolation, which is a very cool feature which nobody else has. You can just run the same application in different namespaces on top of the same cluster, so you can create a shit ton of test environments and creating a namespace of Kubernetes I was showing you is zero effort. Also on the part of the orchestration system. So it takes like a millisecond to create a namespace and you can start deploying into it. So with that you have like ad hoc environment creation and any number of test environments practically solved. It can run on cloud and bare metal, so you can run it anywhere, which is actually a feature of pretty much all container orchestrators except Amazon ECS, because that only works inside Amazon. So I will be doing my Kubernetes demo. How much time? Okay. Yeah, I will be doing my Kubernetes demo on my laptop. I don't need internet for that because it is an open source project that I can just start up on my laptop. See the cloud world before container orchestration, right? I couldn't do an AWS demo without an internet connection. I couldn't run Beanstalk application on Beanstalk on wherever. These were very walled gardens before, and now container orchestration tools are breaking through that. Everybody now, both Google and Azure, are running a managed Kubernetes. So that means you run on their managed service, but can take away your application together with the orchestrator and run it somewhere else if you decide so, or just switch between cloud providers. Let's see how long Amazon will last without officially supporting Kubernetes, but you can still run it on Amazon, just you will have to maintain it yourself. Yeah, and it's also legacy app friendly. There is a bunch of small little features inside Kubernetes that make it the best platform for running. If you need to like port legacy applications that you like don't want to completely change, but you still want to run them on together with your other applications on your container orchestration system. For example, Kubernetes can inject configuration in the form of a file onto the volume in the Docker container. It's such a tiny little thing because the container orchestrators usually inject configuration in the form of environment variables, which is great usually for applications, but so many legacy applications just depend on that configuration file to be there. And once your containers starting up on any one of a huge number of servers, it's a hassle to how to like pull that configuration file. You actually have to code, let's say, pull it from S3 or somewhere, and then you're like building stuff. But Kubernetes just takes care of that for you. And it has the cloud native foundation behind it, so it has been the cloud native foundation. Who knows what the cloud native foundation is here? Okay, so the cloud native computing foundation is an offshoot of the Linux foundation, created by Google and a few other companies, and now joined by both Microsoft and AWS, so everybody is onto that stuff now, to basically guide the evolution of these cloud native technologies. The first thing they took on was Kubernetes, but there is more and more technologies under their umbrella. Basically what it means for users of Kubernetes is that there is not one company, even though this was started by Google, still the main development is done by Google, but it is governed by an independent body on which AWS and Microsoft, for example, have as much say as Google on how the evolution of the platform will go. So, let's get into Kubernetes. Any questions so far? Now I'm stopping all my DevOpsy stuff and going deep into Kubernetes. So, yeah, ready? The architecture I will be only showing on a very high level, don't have time to go into the details, but basically there is a bunch of master nodes. One is enough, but for high availability you might want to run more, 3 or 5, etc. Laura, there, I see. Just learned that. And worker nodes. So the worker nodes will be the one running your containers. These are all, a node is a VM, basically, or a physical machine. Oh, by the way, that's also great. If you have physical machines, you can just run Kubernetes on top of them without anything in between you and the hardware except Linux. So the worker nodes all have an agent called a kubelet that is running on them. Sorry? Oh, okay, that's useful. But the microphone is here, so. But I can at least switch. That's still waving around a lot with my hands. Oh, and yeah, the laser. Yeah. So that's cool. Thanks. Lasers, right? So the worker nodes will be the ones. I should have drawn some containers here. They run your containers. That's the main thing you want to achieve. Have a uniform set of machines and just run the containers wherever it's a good idea to do that. And what's a good idea is decided by the master nodes. So there is a thing called a kubelet that talks to the master talks to the kubelet, and together they make sure your containers start up. And then kubelet talks to Docker on the machine or some other container engine. Yeah, so also the role of Docker here is a bit diminishing because you can run Docker containers, but you can run other containers. Your main thing you'll be dealing with is the container orchestrator, not really Docker. That's just like the lowest layer of the stack here. The master will have an API server. Kubernetes has an awesome API, by the way, as do other container orchestrations, including Docker Swarm and Mesosphere, DCOS, Amazon ECS. So they really all of them did a good job on the API. They kind of influenced each other. And there is a very nice high-level API for you to check the state, run things, etc. I'll be showing that too. Controller manager is an internal component running the control loops of the cluster that continually check whether the cluster state matches what you specified for the cluster. So the control of the cluster is completely declarative. You don't tell the orchestrator to do actions, you tell the orchestrator what your end state is, and it will make sure that end state kind of happens. Which is great, because if something happens to the current state, it can get you back into the end state. You don't have to like, oh, my container died, what do I do now? You don't have to care about that. And then the scheduler is the one that decides where any container will run. When the controller manager decides new containers needs to be started, the scheduler will decide where to start them. And then the heart of Kubernetes is actually etcd. That's the distributed database that holds the cluster state. So when you're running Kubernetes in production yourself, you want to back up the etcd state. If in case something goes horribly wrong, then you can restore your cluster. So running several masters is a good idea, because then you have high availability of the masters. But if the master actually goes down, your cluster doesn't die. Everything keeps working, but you cannot execute new actions or change the state of the cluster. So that's why you will want to keep that one up and running, and probably run it in a high available setup. Yep. So the logical view of Kubernetes, what kind of objects? So basically how Kubernetes works is you create a bunch of objects inside it, and then, I'll check the time, so I have time for the demo. Okay, I have 10 minutes, so I'll jump to the demo real quick. Basically how you describe your applications to Kubernetes is you create a deployment object, and that deployment object through a replica set, disregard this now, will create pods. Pods are your containers. They call it pods because you can run several containers packed together as if it was kind of a single thing. So think of them as containers. Whoever didn't work with this stuff before, just think of pods as containers. And that's a process you want to run, like your web server, for example, is a pod. So deployment will tell Kubernetes, I want to run 5 instances of my web server, or 3 in this case. This is like the front-end pods. And then Kubernetes also does a lot of networking for you. So basically it creates a virtual network using different methods, because it's a pluggable thing in Kubernetes, how that is actually achieved, so no time to go into that. But once you run a whole bunch of instances of a service, you need to access them at a stable endpoint. You cannot track where these run. They all run at some IP address on some port of some VM. But Kubernetes gives you the feature of services. You create a service and tell it to load balance all these pods, and then the service will even create a DNS name automatically in your cluster, and you can just access http://frontend, and that will actually forward the request to the right pods on the right VMs wherever in your cluster. This way you achieve this really cozy cloud feeling where you really don't have to care about where your stuff is running. Oh, and then you can like add in an autoscaler, and that will monitor the CPU usage and can scale your pods up and down over the cluster. And then there is extra things like stateful sets, batch jobs, and daemon sets for other types of workloads. So for example, stateful set is for databases that need like precise instances. Too complicated to go into that now. That's for databases. Batch jobs are batch jobs. Run every whatever time you tell Kubernetes to. Actually, distributed batch job execution is an awesome thing. So that's not something achieved very easily. Actually, it was added later into Kubernetes also. Some orchestrators still don't have that, because it's hard to implement. And daemon sets are a type of workload that runs one container on every one of your nodes, one instance of that container. Really great for log agents or monitoring agents. You just specify, right now, many or like most actual log aggregation and hosted monitoring solutions just support like downloading a Kubernetes manifest file, which is like 10 lines long. Just apply that to your cluster and it runs the log agent, and that's it. No longer have to go to machines and install stuff. So this will be the awesome application I'll be demoing. It has a front end, a back end, and a database. And the database is also just a Node.js process, because I wanted to make this very simple to just show some Kubernetes features. I will be running this on Minikube, which is a single node version of Kubernetes. Basically one VM running all the Kubernetes components, the master and the worker components. So this VM will be running my master and will be launching containers right next to the master components. Very bad idea for anything even closer resembling production. Very nice for talks and also local development. Yeah, so this is how it looks like, everything in that Minikube VM. So yeah, okay, here. So there is my Minikube VM. Awesome. It was printing something a while ago. Let's test if my cluster is there. It is there. Okay, so let's see how my applications look like. This IDE has a nice presentation mode. Awesome. Okay, I can zoom back. That's great. So is it visible in the back now?
Yeah.
Awesome. Okay, this is some Node.js code. You don't want to see that. What you do want to see is how this is described to Kubernetes. So here is my deployment. I'm specifying a strategy for rolling updates. It says the maximum number of unavailable pods is 10%. This means that there will be at least, I'm a bit confused about this right now. Anyways, this will create a rolling update mechanism where when I'm if a service has multiple instances, it will be replacing them one by one when I'm updating it. It's really beautiful how this works, you'll see. Except it's so fast that hard to actually follow, but yeah. The next one, here comes so you can label stuff in Kubernetes, which becomes very useful once you get a bit into the more advanced level, what you can do with labels. Everything works with labels. It's a super flexible and simple mechanism for doing stuff. For example, you label pods in a certain way, like backend, and then I create a service that will load balance between those pods. And then in the service, I specify that I want to load balance between all the pods that are labeled app backend. And that way, for example, I can take away a label from a pod and then it doesn't get traffic routed, and this kind of magic stuff I can do. So I specify my containers. This name doesn't really do much, but this is the important part. This is my EasyKube backend. This was originally created for a talk called Kubernetes the Easy Way on Google Container Engine. I'm specifying how much CPU will this container need. It's 100 milli-CPU, so 0.1 CPU cores at the least. How much memory will it need at least, and when shall it be killed if it tries to use more. Like with CPU, it will only see that much CPU, but with memory it could start using more, and then it gets killed and gets restarted immediately. So if you have applications with memory leaks, then this is really cool. That's a nice band-aid. Health checks, another awesome feature. You can specify a health check endpoint, and that will, Kubernetes will be polling that endpoint and shut down the container if it doesn't respond. It's very simple this way to keep your applications always running without any operator interruption. Another important thing to mention about this file, this is the interface I was talking about between ops and dev. So there is a lot of stuff in here, and developers sometimes are a bit reluctant and try to push this to ops, like write my Kubernetes file, but that shouldn't be the case. Don't allow operations people, don't allow that to happen. This is the stuff that describes the application. This is the stuff that developers should know best. Operations should help, like, okay guys, like giving 4 gigabytes of memory might be a bit too much, or like we don't have 20 CPU machines if somebody would like to do this, so that container will never start up. But besides that, developers should be fluent in this, and this should be the way they describe their applications to operations. And with that, by operations, I don't mean like operations take this file, but just developers can just apply this to the cluster. Yeah, so we were checking the liveness probe. The readiness probe is the same thing except for startup, to see that when is the container first contained state healthy, considered healthy, define ports that this container will expose, and define environment variables. And you can see here that the environment variables will actually be, you could define a value straight here, just say that the database user is a DB user or something, caps lock is on. But what you can also do is load that configuration from a config map. So Kubernetes is already managing a distributed database for you at CD, right? So it can just host objects called config maps in that etcd and inject them into your application. So basically it becomes also your runtime configuration management platform. You don't need anything else, basically. You will need, it also supports secrets, and not in a very nice way yet. It doesn't encrypt them when it stores your secrets in etcd. So that's something you might still want to do in some special way. But it supports secrets objects, and it will soon be... Oh no, I think in beta they already do. They already have some beta feature to encrypt secrets. So that's also like coming big time and fast. Actually, things are sometimes coming so fast. As a consultant, I'm having a hard time keeping up. So that was our deployment. And here is the service. This is it. This is all you need to expose port 8080 of all your containers that have the selector app, or that have the label app backend over port 80. And the type is node port. That's not so important. Interesting thing to know is that if you type load balancer here and you're running this on an actual cloud provider, you will get a cloud load balancer spun up behind the scenes for you. So Kubernetes kind of takes over management of your cloud environment. Ooh, time flies. Is it that? Can I start up the application? Just quickly show it?
Just 1 minute.
Okay. So let's deploy this. So I will create a new namespace. Oh, and it doesn't zoom in. Okay, well, you'll have to see that. Zoom in. You guys to zoom in somehow. So Kubernetes, kubectl is the application I'm using to control the Kubernetes cluster. I create a namespace called Istanbul, and now I will be using my deploy script. Oh, I have to create a variable minikube namespace, so it actually deploys to that namespace Istanbul, and I have my little deploy script that deploys database version 1. That's how fast it goes. Oh, and here in the other, I will just do a watch kubectl get pods namespace Istanbul. So you can see that our database pod is already running there. Backend will actually fail to run. You will see why, because I didn't create the config map yet. And frontend, I think I have version 2 of that. So now everything is running except for backend. I will just have a create cluster script here from where I copy this line. This is creating the configuration map with the username and password. And I have to, oh my god, what's happening here? Namespace equals Istanbul. Yep, it has been created, and now the backend is running. You can see that reconciliation loop happening there, right? So the backend failed to start, but it keeps trying. It keeps trying, and at some point it will succeed if the conditions become right. So that's a very important concept in Kubernetes, that I didn't have to restart the backend because it failed once. It will just try to get to the target state on its own. And now I think there is not even much point of actually showing you the application at this point, but like just do that. So service frontend, and somehow I need to specify the namespace. Oh yeah, that's -n Istanbul. Hooray! So this looks weird because it's here. It actually, there should be an enter here. It's a beautiful website, by the way. I'll be winning design awards, I hope. So I wanted to like update it to a newer version that actually displays it correctly. But anyway, so this actually just generates a random word from the database, and here you can see the host. So this is now load balancing between the front end. So if I like refreshed it a lot of times. You saw that front end changed, or isn't it changing? Why isn't it changing? Sometimes there it changed. It's actually acting sometimes really weird, like as if there was sticky sessions, but there are none, and still it's just loading from the same place for who knows what implementation detail reason. All right, so that's all I could show you of Kubernetes today. But please come to me, ask questions. We can talk about it more after during lunch and so on. Thank you.
We can have a question if anyone wants to ask a question.
Yeah, if we still have time for that, then just shoot.
So I know that like etc daemon also runs on CoreOS.
Mm-hmm.
So how do like CoreOS and Kubernetes run like side by side, or one on the top of each other?
Well, I think anybody who, for whatever reason, already runs that CD could use that CD and give it to Kubernetes. It's just a resource issue from then on. So if you're already putting it under heavy load, then it might be a good idea to give Kubernetes another one. But it's like a operational decision. If you're like running a highly available etcd cluster with backups and everything installed and you're not really using it for much, then why not give it to Kubernetes to use it too? So I think you could use that on CoreOS. I don't know what's actually the recommended way. So CoreOS might have some recommendations. So when you run Kubernetes on top of us, use the etcd that we already have, or please don't use it because we use it for something else. I'm not sure what's the recommendation there.